for this. You've just started a 20-minute exposure, and Rohit and Megha, if you can see my screen, the thing that I'm pointing to, you'll see the exposure is in progress. It's only finished 8% of, this is the total exposure time, 1320 seconds, which is 22 minutes. This is the blue half of the spectrograph, and the red half is over there, and there it's doing 4 5-minute exposures. 300 seconds is 5 minutes, and whereas here it's doing 1 22-minute exposure on the blue side. But this might be a good opportunity to play the podcast. I can play it since I'm sharing sound. I'm happy to play it. Elisa, will that be distracting?
No, I don't think so. We have some time now. Yep.
We have some time, okay. Again, I'm just letting, oh, John has just joined. Hi, John. John, we're about to play this very futuristic thing, a podcast that was generated by AI.
Welcome, everyone. Ready to dive into some seriously cool galaxies? We're talking ultra-diffuse galaxies, UDGs for short. And there's some new research coming up that should blow your mind. We're going to be focusing on the work of Elisa Toloba, GuhaThakurta, and Eric Peng. They're using the Keck telescope to, well, basically trying to weigh these cosmic mysteries.
Yeah, the thing about UDGs, right, is they're huge. I mean, often as big as our own Milky Way, but so faint.
Whoa, wait, big but faint. How does that even work?
Think of...
First of all, isn't this crazy? They sound like two real people. They just sound like two real people. And I mean, it sounds like a man and woman are just talking.
Yeah.
It's crazy. And they pronounce my name correctly, which is what most of the world doesn't know how to do, right? So anyway, I'm going to play it again.
Picture our galaxy, all those billions of stars, now just like turn down the dimmer switch way, way down. That's a UDG. Super hard to even spot them.
Okay, that makes sense. So we got these giant, dim galaxies hanging out in the universe. But why are astronomers so obsessed with them? What makes them so puzzling?
Well, there's two big mysteries with UDGs. First off, their size, right? Massive, but with way fewer stars than you'd expect.
Like a cosmic ghost, taking up space but barely visible.
Exactly. And then there's the whole globular cluster thing.
Globular clusters. Remind me, what are those again?
Oh, right. Sorry. They're like these dense little swarms of stars that orbit a galaxy, right? And some UDGs have tons of them, others barely any. Really weird.
Isn't that so well stated, right? Very simply stated, right? Elisa, the SN varies greatly for, like, the specific frequency of globular clusters varies greatly, right? This is Sung-Soon's.
Yeah.
I think of Sung-Soon's work as the main person showing this. It's so clear. It's so clear. It's so it's such a powerful tool. So I found out about this in September last year for the first time. I mean, other people are aware of it for longer, but Lisa, I don't know if you remember her, but this was one of the students from Castellar School. Her dad is the 26th employee at Google. And
oh, yeah.
Jeff Dean, right? So he's been a huge help. I mean, he and his wife have been supporting CREST.
What is his name?
Jeff Dean.
That's the dad?
The dad's name, yeah.
And the student? So the kid?
Victoria.
We work with her. Is that right?
Victoria worked with deep data early on, looking for Lyman alpha emitters back in 2011 and 2012. Third and fourth year of SIP.
Nice.
So Jeff told me about this. And what I said to him was, Jeff, this is so scary. He said that you can feed in a PhD thesis and it'll give you a summary. And it really sounds like two people are talking. But this feature of being able to interject a question. Anyway, I'll play a little bit more of this.
So two mysteries. Massive, but with few stars and all wonky with the globular clusters. And how do those Keck observations come in? How do they help?
They're all about figuring out the dark matter situation in these UDGs. See, dark matter, it's linked to a galaxy's mass and how its stars move.
Hold on, I'm getting a bit lost here. How do you weigh a galaxy, especially one made of invisible stuff? It's millions of light years away.
It's all about this thing called velocity dispersion. Imagine, picture a highway, right? If all the cars are going roughly the same speed, you'd think the road's pretty flat, yeah.
Makes sense. No hills or anything to slow them down or speed them up.
Exactly. But if you see cars suddenly slowing down, speeding up all over the place, you gotta think there are hills or curves messing with their speed.
Gotcha. So, same idea with galaxies.
Yeah, if the stars are all moving at similar speeds, it means there's not much mass pulling them around. So, probably not much dark matter. But if they're going crazy, different speeds all over the place, that's a high velocity dispersion.
And high velocity dispersion means?
Lots of mass, probably lots of dark matter yanking them this way and that, like those cars on the highway, remember?
Ah, okay, now it's clicking.
We were talking about traffic in India. This is perfect, right? Because India is a very dark matter dominated traffic, whereas you have laminar. Well, I mean, I don't love the explanations, not all of them. I mean, I don't love all the analogies, but still, it's remarkable that this is just done with a bunch of, AI tools. Anyway. Rohit, well done. Really amazing that you dug into this well.
I know it's all Google. I did a little bit part of it, just uploading and fine tuning it and stuff.
Well, I mean, you figured out how to use this tool. Very powerful. Because I had a meeting yesterday with Jamaica, and we were strategizing about how to make Shadow the Scientist more accessible to students. So I was sharing some of the, having these available makes it so much easier for students to understand what's being discussed.
Oh, definitely.
But Rohit, we have to, so Rohit's mother teaches in a coaching center, right? Or she runs a coaching center after school in a small village, Elisa, in a small village between two fairly major cities, Kolkata and Patna. This is where Rohit grew up. But Rohit is studying in the US now. His mom is still coaching there and we should try to get them a laptop for the school, for the coaching center. Google actually donates laptops when they're not, when people stop using laptops, they donate them. We should absolutely get them either an iPad or a laptop, some device where they can, some device that's a little more powerful than a phone.
Definitely.
Yeah, and it's internet is relatively new there also. It's now the internet work is better, but it's just 4 or 5 years back. Like before that, we didn't have internet, so it's nice now.
And Rohit, your own story is absolutely amazing, right? I remind people that Rohit learned English through an app, through Duolingo.
Wow.
And now, he's finishing the 4-year college, astrophysics major. He's writing 2 papers. He's actually, Elisa, you remember Bob Williams from Space Telescope, who Sandy's colleague, who's running the Osterbrock Leadership Program. So Bob is a co-author on this paper. So we're writing a paper on Rohit writing this paper on Wolf-Rayet stars in M33. So it's a remarkable
Nice.
feat. I'll play a little bit more of this podcast.
So they're basically looking at the star traffic in UDGs to see how much dark matter they're packing. But why Keck specifically? Why not just any old telescope?
Well, these UDGs, they're so faint, like we said. You need a heavy hitter like Keck, one of the biggest telescopes out there, to even have a shot at seeing them. Think of it as a giant light bucket, catching every stray photon from these faint galaxies.
Okay, so Keck is giving us a glimpse of these dim galaxies. And they're not just looking at the UDGs themselves, right? What about those globular clusters we talked about?
Good point. Yeah, they've been studying globular clusters around these UDGs, and what they found is, well, let's just say it's a bit unexpected. Some of these UDGs, they got globular clusters zipping around way faster than they should, given how faint the galaxy is.
Whoa, so like finding a feather that weighs as much as a bowling ball? Something doesn't add up.
Right. Like, there's got to be more to these galaxies than we can see, like way more. And that brings us to this whole idea of failed galaxies, which is super interesting.
Yeah, failed galaxies. That's the idea that these UDGs, they started out like any other galaxy, all set to become big and bright and full of stars.
Like budding superstars of the galaxy world.
Exactly. But then, for some reason, something happened. Like they hit a cosmic speed bump.
And instead of becoming these grand spirals, they just kind of faded away.
Right. They kind of stalled out, leaving them as these faint, spread out things we see today. But here's the thing. The stuff that was supposed to make all those stars, well, it might still be there, just hanging out in the form of a huge halo of dark matter. Ah, okay. So they're like these cosmic underachievers with all this potential, but just never really made it big. But we were talking about those globular clusters before, and how their measurements could be a bit misleading, right?
Right. Those globular clusters, they might not actually be part of the UDG, you see. Like, imagine you're driving on a highway, right?
Oh, they're talking about possible non-member contamination, right? It's very well explained because
And there's this car that comes zooming in from another lane.
Okay, cuts you off maybe.
Exactly. And then, boom, it's gone off the next exit. Didn't really belong there in the first place.
Got it. So some of those globular clusters could just be passing through, making the galaxy seem more massive than it really is.
Exactly, like those rogue drivers messing up the traffic flow.
sorry,
And that's where
Rosalie.
the Keck observations come in, right? They're going to look at the stars inside
Hi,
these
thanks so
UDGs,
much.
not just the globular clusters around them.
So it's like, instead of relying on potentially unreliable witnesses, they're going straight to the source.
You got it. They want to see how those stars are moving. If they're all over the place, high velocity dispersion, then that supports the failed galaxy idea. Lots of dark matter hiding in there.
Okay, so let's say they do these Keck observations, and the stars are indeed moving like crazy. What does that tell us?
It means those UDGs, they might be way more massive than we thought, hiding all that dark matter like a secret stash. And it means maybe they really were on track to be big, bright galaxies, but something went wrong along the way.
So like a cosmic mystery, we got to figure out what stopped them from reaching their full potential.
Right. Was it something inside the galaxy itself?
Mm-hmm.
Or maybe something outside, like did they run into another galaxy? Or got messed up by all the hot gas in the cluster? Lots of questions.
This is getting exciting. But what if those stars aren't moving that fast? What if their velocity dispersion is pretty low?
Yeah, that would be a curveball. It would mean those UDGs, maybe they're not so massive after all. Maybe they're not failed galaxies at all, but something totally different.
So not just underachievers, but like a whole different species of galaxy.
Yeah, exactly. Like maybe they formed differently from the get-go. Started out with less dark matter or something.
Okay, so either way, these observations are going to teach us something new. Whether these UDGs are failed galaxies hiding a ton of dark matter or something even weirder. We're talking about potentially rewriting our understanding of galaxies here. But hold on, you mentioned earlier that this could also impact our understanding of dark matter itself, right? Can you unpack that a bit?
Yeah, sure. Remember we talked about those UDGs that seem to have hardly any dark matter? They're like the ultimate puzzle. Because everything we know about galaxies says you need dark matter to make them in the first place.
It's like the cosmic glue that holds everything together, right?
Right. So these dark matter deficient UDGs, they're like a glitch in the matrix. Like, how did they even form if they don't have the basic ingredient for a galaxy?
It's like trying to bake a cake without flour or build a house without, well, anything to build with.
Exactly. So these observations with Keck, they could tell us, are these UDGs really as weird as they seem? Or is there something we're missing about dark matter itself? Maybe our understanding of it is incomplete.
Okay, so we're talking about potentially rewriting the textbooks on galaxies' A&E dark matter. It's a lot riding on these observations. But before we go dreaming up Nobel Prizes, tell me more about this amazing technology that's making it all possible. What's so special about Keck and these instruments, KCWI and KCRM?
Well, Keck is one of the most powerful telescopes we have, right? And those instruments, KCWI and KCRM, they're like Keck's secret weapons. They let us see things in these galaxies that no other telescope can.
Yeah, so picture this, right? You're up on Mauna Kea in Hawaii, where the Keck Observatory is.
Okay, I'm picturing it. Volcano, stars, probably pretty cold.
Yeah, it's nighttime. The stars are just blazing, super clear skies. And there's the telescope, this massive thing all ready to point at some incredibly faint galaxy millions of light years away.
I mean, I can barely find the moon sometimes. How do they even point it at something that far away and dim?
Well, it takes serious precision, right? They use coordinates from other observations, plus these high-tech tracking.
Elisa, the exposure is finished. Oh, you started, oh, it's finished on the red side, I guess, right? Oh, that was only one of the exposures. Lisa, does it tell us which of the 4 exposures is going on the red side? You're muted.
Sorry. It should be here in the,
Oh, exposure 4 of 4. There we go.
where is it? Okay, yeah. There you go.
Right there. I see, and the blue side has some time to go still.
Yeah, it's at the 82%.
Okay, I'll keep playing the podcast. I'm learning so much about UDGs.
Yeah.
Systems. Got to make sure the telescope is locked on perfectly. So it's like threading a needle across millions of light years.
Something like that. And then once they've got it, the light from that galaxy, it hits Keck's mirror.
Which is, what, 10 meters across? I remember reading that somewhere.
Yeah, a huge mirror made of all these little hexagonal segments working together to collect as much light as possible. Think of it as like a giant, high-tech honeycomb grabbing those tiny little photons from across the universe.
Okay, so they snagged the light, now what?
Now the magic happens. Time for the instruments, KCWI and KCRM. Think of them like super-powered prisms breaking that light apart into its different colors.
Right, a spectrum, like a rainbow.
And I guess this is the KCWI side, Lisa, and then
That's right.
and this is the KCRM side, right? So
Yes.
the red. So the light hits this slicer, I guess, which is instead of an image, it's got a series of mirror strips, right? Instead of and these mirror strips are tilted at different angles, so each one behaves like a virtual slit and sends light into a spectrograph. But this, before it goes into a spectrograph, the blue and red, it goes through something called a dichroic that splits short wavelength light into one side and long wavelength light into another side. So the short wavelength light, the blue light goes into KCWI, that's why this is all marked in blue. And the long wavelength light, the red light, goes into the KCRM side. Cosmic reionization mapper for KCRM, Keck, something reionization mapper, and then Keck cosmic web imager, I guess, is KCWI. Those are some of the science cases that the instruments were designed for. All right, back to the...
Exactly. But this rainbow, it tells us all sorts of stuff about the stars that made that light, their chemical makeup, their temperature, and get this, how fast they're moving.
There's that velocity dispersion we talked about. By seeing how those stars are moving...
Notice he said velocity dispersion the second time. First time he said it correctly, dispersion.
They can figure out how much dark matter is lurking in the galaxy, right? But these galaxies are so faint, I bet it takes ages to collect enough light.
Yeah, it's a long game. Hours of exposure time. Those detectors just sitting there, patiently grabbing every photon they can.
All right, Rohit, I need you to demo something. What if you ask the podcast, did you mean dispersion or dispersion? Will it fix it? How do I do that?
I should have shared the whole chat where I made it. I can do it right now.
Oh, no, you don't have to. You can share your screen. Hi, Anjan. Welcome to Shadow the Scientist. Let me know. I can stop sharing at any point if you want. Lisa, we live in a scary world with all these tools.
Yeah, I can try first and see how it's working.
So Elisa starting a new exposure on the red and blue side. So you can see that over here. It's reading out the exposure. So she's going to start another one. Elisa, you're not yet able to start it, right? While the readout is going on. And then as soon as it finishes, I guess it'll ungray this button. There we go. The red side as well. So Elisa, it's 1320 and 600, or what are the numbers on the red side?
174, 3 of exposures of
3 exposures.
174 seconds.
And this is for sky. This is what
This is
you're
for
doing.
sky. Yeah.
Otherwise, you're doing 3 times, or you're doing 4 times 300, right?
Yeah, that is correct.
You're doing 3 times 174. And on the blue side, you're doing 1 times 600. Otherwise, you're doing 1 times 1320.
Yes.
Okay. I'll try to remember these. I'm going to just, as a reminder, I'm going to put it in the chat. So please correct me. Object is 1 times 1320 in the blue. And plus how many? 4 times 300
4 times 300. Yes.
in the red. And that's for object. And then for sky. And it's a fixed offset to the sky always.
Yes.
Okay. So there you're doing 1 times 600 seconds in the blue, plus simultaneously you're doing 3 times 174 seconds red. I put it in the chat. Let me know if this is correct, please.
Yeah, that is correct. Mhm.
Okay. Okay.
That's correct.
And so, Rohit and Anjan, what we're doing is we're pointing at a galaxy for 22 minutes. Then we're pointing at a blank region of sky for roughly 10 minutes. Then again, we're going back to the galaxy for 22, back to the blank region for 10 minutes. Sky, we're going to a blank region. There's no astrophysical sources, but the glow of the Earth's atmosphere is what we're trying to monitor, and that keeps changing with time. So we're trying to monitor it. That's what sky means, trying to look at this blank region. Object is a UDG. And all of tonight, all of tomorrow night, we'll be studying one galaxy. That's how faint these galaxies are. That's how long it takes with the world's most powerful telescope. And Anjan, if you have a minute, please tell us where you're connected from, Anjan, and which school and how you found out about STS.
Hello, sir.
Oh, hello. Hi.
Sir, I'm from India, sir.
Which city in India are you connected from?
I'm from Kerala state, Kerala,
I see.
south of India, south of India.
Yeah, I know Kerala reasonably well, but which city?
City is it is Ottapalam, Palakkad district, Ottapalam, sir.
What is the nearest major city? Are you near
No, I'm
Thiruvananthapuram?
not near Thiruvananthapuram. I'm near Palakkad.
Is that near Kochi?
It's a 2 hours journey from Kochi, sir.
North of Kochi?
Yeah, no,
So
yeah,
you're
north of Kochi.
so you're in the northern part of Kerala then.
Yes, sir. Yes.
I see. Well, how did you find out about Shadow the Scientist?
Actually, I am in a group called Vidyadan, sir.
Oh
Vidyadan.
yeah, very connected. I'm still connected to all of them, it looks like.
Good. Oh, jeez.
Good thing is it's during an exposure, and let me know. I can easily
Okay. I'm gonna-
restart things.
Okay.
I mean, restart the next exposure, that is, if you need to. Megha, welcome back.
Takes a lot. A very long time to
Hopefully the
get.
second time it doesn't take so long. That's what I,
It does take a long time. I don't know why.
1 minute or more.
Or more.
Oh.
Oh, okay.
Are they back?
No.
Anyway, don't just let me know what to do, or let me know if
Okay.
I mean, it's about 2/3 of the way, so it's got another 3 minutes left.
Okay.
I wish it would tell us, in addition to elapsed time, how much time is left. Looks like it's got about 3 minutes left.
Yeah, elapsed time. It says there.
But
Oh
you know
my
what
God. I don't have any windows.
Don't worry. I'll tell John to restart, to move to object and start the exposure
Mhm.
if needed. What I'll do, Lisa,
No, could not get the data. Error.
sorry,
I have an error.
really?
Terminating all VNC connections.
My connection is still on.
Yeah, but I have an error here.
I'm going out of view on the blue side. Sorry about that. Both sides. Why don't I do that? How do I stop? Got it. And do we change the exposure numbers to 1 for the red, just to end the sequence? Got you. Once it reads out, okay. And same thing on the blue side, right? You have it, you've said it already, okay. Gotcha. So we just abort these short exposures, right? We lost only 2 minutes. Sorry about that. So you've started the blue. Okay, good. I see that. And 4 times 5 in the red. Yeah, they're both running. And you can see the short exposure, there's hardly any signal. You see fringing. And Rosalie, one of my control 0 is complaining, saying, attempting to reconnect to VNC server. My other VNC windows are working. I've temporarily stopped my screen share, Rohit and Anjan and John. No. Um, Elisa, you back on the VNC then? Okay, excellent. And Rosalie, I wonder if I should kill my VNCs and restart because my control 0 is still struggling. Now that Elisa's back, I feel confident doing it. Okay, I'll do that. That might be safer. Okay, so I close it by hitting the red X in the upper left of the window. Okay, let me go to, yep, it looks like it's reopened that. Wonderful, that's great. Elisa, I'm going to go back into view only mode in all my windows, so I'm not interfering with you. So Elisa, I'm now back in view only mode for everything. Oh, I'm sorry to have messed up. What confused me was when I was going to change the exposure time to 1320, it was already showing 1320. Oh, okay. So that's okay. No, that's okay. Therefore, I got fooled into thinking maybe it was already on object, now it needs to go to sky. That's how I interpreted that, but yeah, no, thank you for doing that. No, I'm glad you. I know, especially when the skies are clear. Okay. I think we did the right thing by aborting. It's consistent, yeah, uniform. Just for training purposes, I want to make sure I know what to do. So when we do the object to sky, Elisa, if it's okay, I'd like to do that. So I'm going to turn my, I'm going to make it not view only on control 0. So you said I have to do something in this window, right? The local, this window. What do I type? Is it just up arrow? Got you. I see. It's applying an offset east-north. So it does a, so 2 times because, of course, yeah. No, I'm not going to do it right now. Yeah. And it's 2 up arrows because you're alternating the offsets you're doing. You know, I guess when we next do the offset, we'll be going east and south to go from object to sky. And when we go from sky to object, we go west and north. I'm a quick learner. Looks like it. Not with KCWI. That's true. Yeah. Yes. Uh, uh, so to the folks in the shadow session, what happened was our virtual network server gave us some kind of glitch for Elisa and me. So we had to scramble. So Elisa, a quick question for you on the control 0 window.
Yes.
This blue region, is that the large slicer configuration?
Yeah, the blue box is the large, magenta is the medium,
And then green is the
the
small.
green is the small. Yeah.
And then these little blobs that I'm pointing to, these must be globular clusters in the galaxy.
That is a very good question because there is stuff in the center of the galaxy that are not
The background
global,
galaxies.
that there may be yeah, background galaxies.
It almost looks like the vignetting makes it look like the surface of the moon or something, right?
Yeah.
But this gradient must be just instrumental, not sky.
Yeah, that is the field of view. That is the point in from Keck, right?
Yeah, but it must be some kind of camera vignetting that it's so dark at the bottom and then completely black at the top.
It's because this is the circle and I think that the light is split to go
Right.
the
I mean,
left to
yeah, it's
the
actually this
red and the
image.
blue, so
It's,
that's why you have
yeah,
this.
we are looking at some, like, it's like looking at some portion of this image, right?
Yes. Yeah, exactly. That's what we're doing.
We're looking at like the upper portion of this, right? If you compare this and this, yeah, that's what we're looking at. But these are actual stars in the sky, right? These white spots,
Yeah.
I assume. And that's north and east. How exciting. Okay. I'm ready in control 0 as soon as the exposure finishes. So this is 3 of 4 it's doing. So it's about halfway through. Where did it go? This is about halfway through also, 55%. Anjan, sorry, I hope I'm getting your name correct. If you have any questions, feel free to ask. And Rohit, same for you. Bless you.
Sir,
Yes,
actually, I joined very late, sir. So,
that's
like,
okay. That's
I didn't understand. Like, I could not understand anything. You people have been talking. I didn't get anything from this. So.
no, don't worry. You did what we played for the group. I'll put there's a link. Can you see the chat, the Zoom chat? Are you able to see the Zoom chat by any chance?
Yeah, I can see it.
Okay, what I'm going to do is put something. I've just put a link in the chat, and it's a Notebook LM based podcast about what project we're doing tonight. I encourage you to listen to that. You don't have to do it right now, you can do it later, but it explains what we're pointing at, why we're doing this, how the experiment works.
Yes, sir.
You're familiar with Doppler shift as a student of physics, and Doppler shift of sound you're familiar with. We are really using the Doppler shift of light to measure how fast stars are moving inside this galaxy. And that's telling us about the gravitational pull that the stars experience, which is telling us about the total mass of the galaxy, how much matter it contains. But if you listen to that link, are you able to access the link that I put in the chat?
Yeah, I think like after this, like I can go through the link, no, sir.
That'll be great. Okay. That'll help you understand what you were seeing here. Now, the name on the Zoom, is that your name or somebody else's name? Because Anjan,
It's Anjan only.
okay, that's your first name?
Yeah, yes, sir. Anjan AK. It's my initial is AK, sir.
Got you. Well, thank you for joining, and you're welcome to stay on. Please feel free to ask us questions about, I mean, you can ask us about our own, what made Rohit an astronomer, what made Elisa an astronomer, what made John, what brought him into the profession. That you're welcome to ask us questions about our careers, but also about science, anything that is useful to you. What are you
Yes, sir.
thinking? Yeah, what are you thinking of doing on the and Anjan? Okay, you can see 304, meaning it's taking 4 300-second exposures, so 4 5-minute exposures, with the part of the spectrograph that sees red light. So a telescope focuses light. That light then goes into an instrument called a spectrograph. That's what we are using today. So the blue side is nearly finished. Got 3 minutes left, Elisa. I think they should really put a time remaining on these
It says that
windows.
right there, elapsed time. Oh,
Perhaps
okay,
time
yeah.
remaining. Time remaining would be, you know, they have both for the DMOS GUI, for example. Otherwise, you know, in the middle of the night trying to do subtractions, not
yeah.
easy. Right. And my brain finally computed there was 180 seconds to go or 3 minutes to go, but it would be nice to have that. Especially when this number is complicated, right? When it's 1320, it's not a round number. It's coming up on 2.5, well, it's 2.5 minutes to go. See, I can do math, but it's not easy this hour. Yeah, really, they should have in addition to the elapsed time, a countdown clock.
Mhm. I will add that in the.
Summary.
I will add that in the.
Post observing comments, yeah.
Yeah.
1.5 minutes to go now. Let's see how the red side is doing. So, little more than now 1.5 minutes to go. Which one reads out more slowly, red or blue? Blue side, right?
Blue, yeah.
So these are almost perfectly synced.
Yeah.
That's great. Less than a minute on both sides. So Elisa, should I wait for the readout to finish before moving the telescope, or can I
But you
move
want to
it?
do it?
Yeah, I'm good. I just to practice.
Okay. Now you
sh-
only have to do one arrow.
Sorry,
To move the telescope, only one arrow up.
why is that? Why not two? Oh, because we. No, it should be two still, right? Oh, I see. I see. But we have to wait for both exposures to finish, right? Or they're both finished. -1. Okay. Elisa, is this correct? Okay, I'm hitting enter. John, I'm moving the telescope. John, I'm moving the telescope then. Okay, I won't touch those. I see that you've shortened the exposure times. All right. Elisa, have you started the science exposure on the blue side? I don't see it started on the blue side. Unless maybe my VNC is frozen. Yeah, my VNC, my control 1 is frozen. Because the science exposure button is not grayed out like it should be. In fact, the red side is looking fine, but the blue side is frozen. But you're seeing the exposure progress on the blue side? Mine isn't. That's okay. I know how to kill it and restart it. So I'll do that. At least I'm trying to reconnect to control 1, but it's not happening right away. So the VNC has been quite glitchy today. And I don't know if it's my internet connection or something else. Hey, Laura. How are you, Laura? The famous Laura Sales. Yeah. And Laura, we are running a Shadow the Scientist session. Love to introduce you to some of the people who've joined. Shall I send you a link? They're in a different link.
These are back? Yeah.
Yes, they are.
Good, good.
Yeah. What Rosalie showed me to do, I'm in view only mode for control 1 at least, is you can kill an individual window and just type control 1, control 0 into that prompt, and it just brings that back.
Okay.
So I've got control 1, I've got control 2, I've got control 0, and I've got tell status. All of them are working, and I think I can put myself in view only mode again.
Okay. Right.
I'm back in view only mode, Elisa. But let me know anytime you need me to get out of that.
Yeah. Oh, I'm so glad that you were there.
Well, it's gotta be
Observing alone is hard
no
when
fun.
things
It's
happen.
no fun. The pressure. It's the world's biggest telescope and all that. It's a lot of pressure. You don't want to waste time on it. I already wasted 2 minutes of the world's biggest telescope. I should probably get charged with a fine.
It's okay.
Secret is it's not the first 2 minutes I wasted on the Keck telescope.
Well, it was because the VNCs failed and.
Well, no, what happened was Rosalie had changed the exposure time, and I thought I was supposed to change it, so I changed it back.
Yeah,
That was the bad thing.
exactly. Things that happen. It's okay.
And she was, of course, trying to help, and she was.
Yeah.
All right, there's Laura. Hola, Laura.
Hello.
Hello, hello, hello.
Okay, I transitioned successfully.
Very good. Thank you. You're looking at the blue side of KCWI.
I have
over
no
there.
idea. Okay.
Yeah, no,
Now I saw the blue. Okay.
Yeah, this is blue,
Mhm.
and we are in the middle of 10-minute exposure, sky exposure.
Okay, cool. Oh,
and
skies, not cool. Okay.
so, no, well, no, we need it. But so it's about 2/3 of the way for a 10-minute exposure. And you can see that it's saying 400 seconds, 412, 413 completed out of 600. That's the blue side. And then on the red side, let's see, on the red, that's the blue side. On the red side, it's doing roughly 3-minute exposures, right? 174 seconds. And it is on the last of those. It says exposure 3 of 3.
Yeah.
On the last of those, and it's just starting the exposure. You can see this bar will start to come up here, 1%.
Okay. So it does it in parallel, like at the same time.
Exactly. There's a dichroic. So what happens is the light from the telescope gets focused, goes into the slicer, and the slicer, instead of forming an image, it has these mirrors which behave like virtual slits. Each one sends light in a slightly different direction because they have different tilts. And that, after that, it goes through a dichroic. It splits the light into red and blue. And what you're looking at here is the red side, and what is over here is the blue side. So KCWI side, and this is the KCRM side. And then these are the other control windows, these two.
Cool. How is the weather?
Perfect.
Oh, yes.
It was very bad last week, a lot of
Elisa,
rain.
once.
Congratulations on getting, I think I'm planning to come back to Hawaii in May because we have 4 half nights. So it's always fun to observe from Hawaii.
From in place, yeah, of course. That's fantastic.
Time zone differences. And in the summer, in May, it's a 3-hour time zone difference to California. So, so hoping to come back. And 4 half nights is a nice long run.
So how long do we have in May? So two half nights, right?
4 half nights.
Oh, 4. Oh, I forgot. That's fantastic. Yeah.
Total of 6 half nights, total of 3 nights. 2 in February, second half nights in February, and then 4 first half nights in May.
That's nice. Yeah. So Elisa, will you be in sabbatical or you?
No, and that finished. That is
that finished.
Yeah, that ended already.
Oh, okay.
Yeah, you are in your sabbatical now.
This is a quarter sabbatical. I didn't take a whole year, yeah.
So winter quarter.
So only the winter, yeah.
So you can split it then?
Yeah, so the thing is my partner, she's an experimentalist and they cannot really leave the lab. So he agreed to come with me for a quarter, but more than that, it would be bad for his group. So.
Is it very cold in Germany right now?
No, it's unusually warm. It's around the 0 and a bit negative, but no snow, nothing. There's sun.
So I was in Heidelberg a year ago for Hans Wolter's 60th birthday celebration. It was bitterly cold in Heidelberg. But you're in Munich, right?
I'm in Munich, yeah. We bought all kind of clothing for the snow, and when we just arrived, there was snow and stuff. But then it warmed up, and it's been warmed since.
I see.
Yeah, no complaints.
And Laura, let me introduce you. You know John. John is our... we're going to move the telescope first.
Oh, okay. Let's look this.
Soon. But what we're going to see, we have to wait for this readout. Oh, well, this readout is happening. So what's happening on this side? Readout is happening. So we're going to move the telescope next. So Elisa is moving the telescope in this window over here. Laura.
So you give the coordinates?
Yeah, EN are east and north offset. So it's going to offset from the sky to the galaxy, to the UDG. So as soon as Elisa types that, we should see it. Elisa, have you applied the offset already?
We are observing already.
Oh, offset is applied.
Yeah, offset applied and...
I'm not seeing that on my window, on my control 0. I'm still seeing a negative offset. So my control 0 must be frozen. What do you see on your control 0, the local host?
That the positive offset just went in.
I'm not seeing that, right? You guys are not seeing
No.
that on the screen share.
No.
No.
So
No.
I'm going to kill this window and restart it. Let's see. Yeah, the VNC has been quite flaky.
Is that a VNC from Keck or where's
Yes.
any VNC on?
These are all VNCs from Keck that Elisa is running them on her laptop. I'm running them on mine. And yeah, now I can see the positive offset. Do you see?
Yeah.
It's positive mean it moved east. That's positive, and then negative for south. So it moved east and south to go from sky to the object. Right, Elisa?
Yeah, that's correct.
Okay, and now the exposure, the other windows were fine. So this window, you can see the exposure it's doing a longer exposure now, 22-minute exposure. So
22 minutes. Oof.
so the galaxy exposures are 22 minutes on the blue side and only 10 minutes when it's on sky. And on the red side, it's broken up into 3 exposures because the red side chip is very thick, so lots of cosmic rays. You can see all the cosmic ray hits here.
Those are cosmic rays? Wow.
These very diagonal ones, not the vertical ones are night sky emission lines. But the diagonal ones are, and when they're very long like that, it's because the cosmic ray is coming in at a grazing angle. So it affects lots of pixels along the thing. When it's a short one, it's typically because the cosmic ray came in at more of a higher incidence angle. So we're getting to see solid state physics.
So do we see any of the Starlink satellites bothering us or not really?
Such a small field of view.
No? Okay.
Very, very unlikely. It would be super. So in general, the satellites are only a problem around sunset or sunrise. In the middle of the night, what happens is in the middle of the night, the sun is below us. So even if the satellite is above us, we're not getting any reflected sunlight. The sun has to be off to the side. So that's why it's only at sunset and sunrise we see satellites. It's we're seeing reflected sunlight after all. So near the end of our half night, we may see satellites. But again, it's a combination of facts that makes it very unlikely. Deimos has a huge field of view, whereas KCWI is looking at a tiny patch of sky. So be very unlikely.
Chances are low.
And the exposure we are looking at here was one of the 4 3-minute exposures that we took in the sky position. So you'll see that when this readout finishes, this window here, the night sky lines will get brighter because it will go from a 173-second exposure to a 300-second exposure. And the cosmic rays will get even more because the longer exposure, so more cosmic rays. So in a few seconds, we should see that happen. It's, we're nearly finished with the first. You see it says 1 of 4 over here, exposure 1 of 4. So the first of the 5-minute exposures is about to finish. First of 4. But I think you'll see the night sky lines get brighter because we're roughly doubling the exposure time from 173 to 300. So Laura, I'm actually in Hawaii this week.
Oh, nice. Okay. So you're on site?
I'm in Hawaii, but not on site. I'm in a different town for an outreach event. But I'm in the same time zone, at least. Okay, so here it's reading out. It should start reading out here. When this bar is finished, you'll see the night sky lines will get brighter. And the cosmic rays will all shift. Will be different cosmic ray, different streaks. Okay, coming up soon.